rich set of learning that we can share with everybody. And we're reimagining coal and carbon capture, how that's going to work. And that includes, as I mentioned, advanced combustion, like ultra supercritical, oxy-combustion, different technologies that we're looking at. There's the capture and storage, and again, moving towards the pilots. So again, in our group of the Office of Advanced Fossil Technology Systems, there's carbon capture, carbon storage, advanced energy systems, and then cross-cutting research where I sit. And what we do primarily is we take technologies that are at a technology readiness level of, say, 2 to 4, and we try to take that technology in, help that technology get developed and pushed out to the higher TRL levels so that we can hand it off then to one of these other parent programs, capture, storage, or say, gasification, for instance, in the advanced energy system. So that's our role, is to bring it in, develop it, and then hand it off. And really, the goal of those other 3 programs are to get it out into industry. Again, we don't want to keep it to us. We want to get it out to the OEMs and the plants. So just a couple. I'm going to not talk a whole lot about this slide because we got a late start. But this is just we have a program for hydrogen turbines. Just an example of how these in cross-cutting. Let me back up a second. In cross-cutting, there's 3 major emphases that we have. We're looking at sensors and controls, we're looking at materials, and we're looking at modeling. And so this is just an example of in a turbine, right, there's these different materials that need to be developed in order to realize these higher temperatures. So you have to have better thermobaric coatings, bond coats, base alloys, just in order for the components to survive themselves. There's also opportunity to put sensors in there to better understand how the inner workings of the turbine. Can we, for anybody in the audience, right, familiar with turbines, blade tip timing, blade tip clearances, those measurements are crucial to increasing your efficiencies. And so we're looking at better ways to implement those sensors. Again, that's just a turbine example, right? Same could be said for downhole sensors, right? There's opportunities there as well to deploy these. So we're working within the 3 programs. One of the material aspects of cross-cutting research that we like to highlight is this success story about the development of the Inconel 740, which has since been approved by ASME in terms of boilers and for use in boilers and pipes. And this again allows us to operate at the higher temperatures and pressures that the traditional excuse me, that the traditional alloys wouldn't survive in. So, and then in the modeling, there's two big modeling efforts. We have smaller modeling efforts as well, but the 2 big ones that occupy a lot of our time are the NRAP, or the National Risk Assessment Partnership, where we actually are looking at the how well a storage site could operate and the risks associated with that. And you'll see this is not something that we work on alone. There's a team of 5 different national labs working on that. We have industrial stakeholder groups, and this team with at the bottom there with the URS and some of the regional universities. The second one is the Carbon Capture Simulation Initiative, which again seeks to understand better the technical risks associated with CCS, and applying or defining the uncertainties better of what's going on with that. So all of these are, the end goal is to, again, foster the development of CCS, which I highlighted in my first slide as one of the things that were important. Again, this is led by the 5 national labs, a group of universities, and an industrial. This one actually has an industrial steering committee, and so some of the names you see here are actually, I see one of our speakers is listed there, where they come in and they make sure that what is being done is relevant that we're generating solutions that is actually helpful to people interested in developing CCS. This is I talked about, we just stepped into the water, and this is the latest drought map. I put that in last night. It's anybody from the western states realize that California's in a severe drought right now, but if you go back just a couple years ago, you'll see that in 2012, right, that's a different scenario of what was happening. You go back one more year in 2011, it's centered there in Texas. And so this challenge of climate variability and where water is suddenly becoming not just free and flowing, but it's becoming a restricted resource. How can we develop solutions? This is a Sankey diagram from our Water Energy Nexus webpage, the opportunity and challenges. They issued a report recently, and what I just want to highlight here